Hello and welcome to the last section of notes for this chapter on parallel lines and proportional parts. First theorem we're going to learn about in this section is the triangle proportionality, aka the side splitter theorem. And what this says is if a line is parallel to one side of a triangle, so like here BD, and intersects the other two sides in two distinct points, B and D, then it separates these sides into segments of proportional length. So basically what it's saying is BC over AB is going to equal CD over DE. But as always, I could write these in different orders if I want. So I could write BC over, say, CD, and that would equal, if I started with BC, which is the left side of this triangle, I would have to start with AB, the bottom part, over the bottom of the right side. So let's look at our cross products here. I would have AB times CD. Oh, AB times CD. Over here I would have BC times DE. Over here I would have BC times DE. So those are the same. I could write this another way. Let's say I wrote BA over DE. So the bottom left over the bottom right, that would equal the top left over the top right. Notice my cross products, if I was to find them here. BC times DE, just like these. And that would equal AB times DC, AB times DC. So now what's important though is they have to be parallel. If you don't see those parallel sides, you're gonna have to check if the triangles are similar in some other way, but you can't use the side splitter theorem unless there's a parallel side. And I can move this parallel side. I would be able to do it on notability, I can't here, but if I move it up here, it's still the same. It cuts the sides proportionally. Notice how the third side, this one and this one, have nothing to do with the proportions that I set up. If you are looking for BD, you're going to have to do it a little bit differently, but we'll do examples where I'll illustrate that. The converse of the side splitter says if a segment divides a triangle, two sides of a triangle into proportional segments, then the segment is parallel to the third side. So here you would say if you find that BC over BA happens to equal CD over DE, so really these should not be here because we're checking if that would be true. If that's true, then we know that that segment BD is parallel to AE. Remember, converse is the opposite. So like if I know that these two lines are parallel, then if this is 70, I would know this angle has to be 70. If I want to check, are these two lines parallel? Like parallelity is the question. Well, if this is 70 and I find that this is 70, then I could say yes, the converse of corresponding angles theorem says that those two lines have to be parallel if those two angles are congruent. So it's kind of just the reverse. Our first example here says IS is parallel to NE. NE is going to equal 24. LS is 12. LE, this entire thing, is 20. And IN is 6. We want to find LI, let's call that X, and we want to find IS, let's call it Y. The first thing I noticed when I was filling in these side lengths is that I was given this top portion over here, and then the entire thing, 20. So in my mind, automatically I thought, well, I know then that this is 8. So I could solve for x by saying x over 6 is going to equal 12 over 8. I could simplify 12 over 8 if I want and reduce that fraction. I don't have to though. 6 times 12, so I'm going to do cross products. 8 times x is 8x. 6 times 12 is 72. So x is equal to 9. So now that I'm looking for y, which is what I was referring to earlier, I cannot use side splitter theorem, meaning I can't say something like y over 12 equals 24 over 8. That is not the side splitter theorem. The sides that get intersected by that parallel, these sides get cut proportionally. The piece that's not intersected, which would be IS or NE, that is not the case. However, because these are parallel, I know this angle is congruent to that one, corresponding angles, and this angle is congruent to that one. So what I have is two congruent triangles. I have ISL, and then the entire triangle, where I have one arc, two arcs, is NEL. Okay, so let's fill in what we know. We are looking for IS, that is 6. I know LI is if I found x is 9, this side is 15, this side's 12, ls. For the bigger triangle, oops, so that shouldn't have been 12, sorry, or 15, that should have been x, which is 9. This side should be 15. Okay, and then NE is 24, this is 20. So because I'm looking for y corresponds to 24, and then, oops, unless I didn't put 12 there, I could use either one. I could use 12, sorry, I'm trying to do the highlighter. 12 goes with 20, or I could use 9 and 15. So any combination of those I can use. So let's say y over 24, and then I could write either 9 over 15 or 12 over 20. I'm going to go 9 and 15 because those numbers are smaller. So cross products 15 times y is going to give me 15y. 9 times 24 is equal to 216. Divide both sides by 15. Divide both sides by 15, I get 14.4. That is exact because I did not have to round that, but if I want to write it as a fraction, I math frac it on my calculator and I get 72/5 for y. Okay, so just one thing that is a very, very common mistake that students make is they'll take this over 12 and equal it to 24 over 8. And that is very, very incorrect because y is the entire side over 12. And if you do that, you know, y over 12, so if you go this bottom side to the right side, you have to do the same thing for this big triangle. You'd have to go bottom to the right side. Or if you want, you could do the bottom to the left, but then you have to do bottom to this entire left. So you have to add up those two side lengths. Next thing we're going to learn about is the mid-segment theorem, and we've talked about mid-segments before with trapezoids. Now it's going to be a segment connecting two midpoints of a triangle. So here are the two properties. It is parallel to the third side, and it's going to be half the length of the third side. So because this is a mid-segment, MT becomes congruent to TP, and MI becomes congruent to ID. And it's parallel. So it's always half the length. So if this was 2, this would have to be 4. If PD was 20, TI would be 10. Okay? How would we prove it? Well, these triangles would be similar by... Let's take a look at this problem. It says that the entire perimeter of the big triangle, PD, is equal to 102. And then it says T and I are midpoints. We're going to add in a point here. We're going to say also S is a midpoint. So that means if T is a midpoint, it splits this side in half. If I is a midpoint, it splits this side in half. And if S is a midpoint, it splits this side in half. All right, all of these are parallel to the third side. So therefore, if this is 72, this is 72. If this is 28, this is 28. And then let's start looking at side lengths. Okay, if this is 15, if that mid-segment is 15, that means the third side, the mid-segment is half, it has two properties. It's parallel to the third side here being PD, and it's half the length, which means this is 30. But now, because these are midpoints, because this gets split in half, we know each of these has to be 15. This has to be 15. Okay? Same thing here for this mid-segment. If this is 11, that means this entire side has to be 22. It's double it, which makes this 11, it makes this 11. So now we could find MD. How are we going to find MD? Well, the whole perimeter is 102. Right? They told me that right from the get-go. They said the entire perimeter of the whole triangle is 102. So what I would do is 102 minus 22 minus 30. What does that leave me with? It leaves me with MD. This entire thing has to be 50, which makes this 25 and this 25. So what I have now is a bunch of little triangles. All 4 of these little interior triangles are all congruent to each other. Because if, so I'm going to just, one more thing I'm going to write here, is this has to be 25 right here. Okay, so I have 4 triangles that are all 11 by 15 by 25. They're all congruent to each other. So now I can figure out some angle measures. if this angle is 72, notice that's the included angle between 11 and 15, those two sides. So over here between 11 and 15, that's 72. This side between 11 and 15, that's 72. We already knew that. Let's look at 28. 28 is the angle that's included between side 15 and side 25. So this is 28 between side 15 and side 25. So this is 28. X, by the way, I forgot to include that one, between 11 and 15, that's also 72. Those angles are all congruent. So therefore, X is going to equal 72 degrees. Now let's solve for Y. Well, Y is a segment. It's this segment right here. We know that it equals 25. Let's write that equation for Y. 3Y minus 2 is going to equal 25. Add 2 to both sides. 3y is going to equal 27. Divide both sides by 3. We get y equal to 9. So we have found our two variables that we were looking for. Couple of corollaries here. If 3 or more parallel lines intersect two transversal, then they cut off the transversals proportionally. And if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on all transversals. So basically what this is saying is if I have 3 or more parallel lines, so I'm going to try to draw 3 parallel lines here. If I draw two transversals, so let me actually make my arrows here for my parallel lines. Two transversals, what this is going to do is it's going to chop these sides up proportionally. So I'm going to label this segment 1, this segment 2, and then I'm going to add actually one more parallel line. So this will be 3, 4, 5, and 6. So what this does is it sets up a bunch of proportions, like 1 over 4 will equal 2 over 5. 2 over 5 could equal 3 over 6. 6 over 5 would equal, if I follow this pattern, 3 over 2. Now what else I could do is I could say, okay, well I'm going to add these two. So 1 plus 2 over, let's say, 3. What would that be proportional to? Well, I have to follow the pattern. It would be 4 plus 5, those two segments, over 6. It just sets up a bunch of different proportions that you could set up. These are actually my favorite problems from this entire chapter when you have this situation, because you could do and find a lot of fun things here. Last example. Someone is building the staircase at the right. Where should the vertical strips be attached at the top? So that means these are vertical. All vertical lines are parallel to each other. So on the bottom here, I'm given this segment, and this segment. And on the top, I'm not given any of them. I don't have X, I don't have Y, and I don't have Z. So it's not like I could, although it's true that X over 2.5 would equal Y over 2.0, would equal Z over 1.5, and I could use any combination of the two of those, I'm stuck here because then I have two missing variables. So what I have to do is consider the fact that this entire thing is 8. Okay, so if that entire thing is 8, what I'm going to do is I'm going to solve for X first. So I'm going to write X over 2.5. And now I'm going to rename this segment here. I'm not going to use Y and X. I'm going to use the fact that the entire thing was 8 and I already took up X of it here. That would make this entire segment 8 minus X. This whole thing is 8 minus the X that I already used. So now if my numerator here, if I write this as 8 minus X, this entire segment is 8 minus X, and I used my gray highlighter, that's going to go with this entire gray highlighted segment. So my denominator is going to be 2 plus 1.5, aka 3.5. Let's solve this by cross multiplying. 3.5 times X is 3.5X. And then this is going to equal 2.5 times the entire numerator, 8 minus X. We get 3.5x equals 2.5 times 8 is going to be 20 minus 2.5x. Add 2.5 to both sides, you are going to get 6x equals 20. Divide by 6 and let's reduce. 20 over 6 is going to equal 10/3. And that's how we get this answer. Now that I have X, I could find Y, I could find Z. So the way I would set that up, let me use some more colors. I'm going to take x that I just found over 2.5. So 10/3 over 2.5 is going to equal y over 2. And then 10/3, whoops, well, it's okay, I just wrote it this way. 10/3 over 2.5 is going to equal z over 1.5. All right, find those two cross products. So here you get 2.5y equals 20 over 3. Here you're going to get 2.5z equals 10/3 times 1.5. Let me just figure out what that is. That is equal to 5. Using my calculator here, when I divided by 2.5, I got 8/3. I got 2.66666, so I math fracted it. Here, dividing by 2.5, you get z is equal to 2. Okay, so that is how you would do a problem like that. And that is a pretty, difficult advanced type of problem. You're going to start off with ones in the classwork that are a little bit easier. Okay, that's it for these day of notes. Thank you so much for watching. Take care of yourselves. Bye.